First of all, apologies for weird letters in my name. Okay, so my talk today is a case study of how we at Lunar Way have been transforming a monolithic backend into a microservice architecture with a special focus on inter-service communication patterns. It's a tale of how we, for the past close to 2 years, have been working on this transformation, primarily into an architecture where services communicate using async message passing. There'll be a lot about the learnings we've had along the way, and hopefully some takeaways for you to bring back home if you are to embark on the same journey. Speaking of which, it would be really interesting to see learn something about you in the audience. So let's do a quick poll. How many of you are running microservices in production? Okay. How many are in the process of getting microservices into production but not really there yet? And how many are just having dreams about microservices? Okay, great. Finally, before I begin, a little disclaimer about size. Size has been talked a lot about, especially yesterday. Stefan Tilkov talked about how to size things and that you also always have to look at things in the right context. And I think it's important to bear in mind during my talk as well what the context is. Lunar Way is a medium-sized startup. We're about 35, 40 people right now, with 12, 15 people in the tech team. So everything I say has to be seen in that context. It might not apply for a smaller startup with only 2, 3, 4 people in the tech team, or a large enterprise. And I'll come back to that later as well. So just a short note about myself. I've been in the software industry for close to 15 years, starting in Java country, and moving on to Scala and functional programming. And right now I'm primarily working in Go and TypeScript at Lunar Way, where I've been for about 2 years. Yeah, and as you can see, I started back in the 80s on a Commodore 64. Okay, the agenda. First, I'm going to set the scene, talk a bit about what Lunar Way is and where we came from. Then a bit about microservices and communication between the services. And this will lead on to the actual journey. And finally, I'll talk about some specific use cases that we've been from our own setup, focusing on async message passing. So what is Lunar Way? From a user's perspective, we are a bank, but really we are not. We're not allowed to say that we are a bank because we don't have our own banking license. The business model right now is to partner up with a real bank and then build our experience on top of that bank's API. We try to be different and more challenging than traditional banks, and challenge the way traditional banks do their business. We are only on a smartphone, no physical branches. And we try to communicate with our users at their level. The primary user target group is younger people with a simple banking requirement. And as you can see from this marketing material, we're present on all the social media. The primary channel for communication with our users is actually Snapchat. Our catchphrase is make money matter, and these 3 words encapsulate what it is we are trying to do. We're trying to make every aspect of our users' money matter. The company is 2.5 years old, and as I said, 40 people divided between our headquarters in Aarhus, in Denmark, and a smaller office in Copenhagen. Yes. Okay, so let's get into the interesting stuff. To start with, let me give you an idea about how our platform looked like in 2016. I started in the summer of 2016, and this is what it looked like. Pretty common setup for a startup. A Rails backend on top of a Postgres database. Then we had 2 integration components written in Java. One towards the Danish partner bank, and one towards the Danish national identity provider called NemID. The reason for Java is that the integration API is SOAP, so Java is a good fit. The app is native, iOS and Android app, and everything is hosted at AWS and deployed using Docker Compose. So it's a static deployment. We were running 3 complete instances of the setup. Some early experiments had been done with microservices, but due to personal preference and considerations of speed, a choice of Rails had been made. And as suggested by Daniel at last night's panel, it might not be a bad idea to start out that way until you get to know your domain model and get going, figure out which direction you're going in. Starting out with a monolith might be a good idea. Okay, but when I entered the company, the monolithic backend we were beginning to see some friction against what the company wanted to do, and also against the way we wanted to organize our development teams. So an assessment of the platform could look like this. The good, the API, the REST API towards the app was nicely structured. There was something to work on there. But when I made this, I tried to figure out, well, what else could I find of good points? Yeah, I found that a bit hard. On the other hand, there was a lot of bad stuff I could think of. The data model on the backend was very tightly coupled. There was especially one entity having threads all over the place. The app and the backend were also tightly coupled on the data model. We did big bang deployments, so if we had to change just a little bit somewhere in one of the integration components, we had to skip it all into production. Therefore, it was also difficult to do fast experiments, and it was hard to scale due to the static nature of how we deployed stuff. So we all agreed that we had to change something. And what we wanted was, of course, scalability, resilience, and especially autonomy. We wanted to be able to run autonomous teams, having the responsibility of a specific feature in the app, and let them have the full responsibility of that. We wanted to, therefore, to decouple the backend, get this tightly coupled data model torn apart. And to do these fast experiments, if business found out that it would be really nice to do this feature, then get that going fast and get it out into production and see if it is something we should continue with. And to support all of that, we wanted small, independent, and fast deployments. So, what's a good fit? This is, of course, where microservices come into our story. It's exactly what a microservice architecture promises. So let's have a look at that. So what is a microservice? Yeah, there's no real textbook definition of a microservice, but some clever people have said a lot about it. Sam Newman says microservices are small, autonomous services that work together. So that's this decoupling. We have small services that somehow work together, but they're autonomous and independent. That's not all of it. Martin Fowler has added some more to this about how the services communicate using lightweight protocols. I doubt that you'd do SOAP between microservices. And he says something about how they're built, how we structured these around business capabilities, the notorious bounded context. And we also need to be able to deploy them individually in an automated way. So if we implement microservices as those quotes describe, it seems that we get all the things that we would really like to achieve. However, the benefits also come at a price. And you have to take that into consideration. Sebastian Cohen this morning talked about, in his talk entitled, Why We Did Not Choose Microservices to Replace a Legacy System. He talked about this, exactly that. If it's not obvious that you have to choose a microservice architecture to achieve these goals. If you do choose a microservice architecture, you suddenly have to think about some of the challenges as well. How are you going to share data across services? How will you do debugging and tracing? How do you do orchestration of business processes across services? Chris talked about that yesterday in his talk about sagas, right? How do you actually handle this deployment of all these services? And how do you handle the runtime platform? There's an increased overall complexity that you have to handle. And finally, how do you provide insight across microservices? When we chose to go the microservice way, we didn't have answers to all of those questions. But we judged the benefits to outweigh the challenges and hoped that down the road we would find answers to these challenges. So one key decision is also you have to decide how are these services going to communicate. So basically you have two choices. You can choose between synchronous, request-response style communication, or asynchronous message passing. So let's have a look at the synchronous request-response first. That's a close type of communication. You have a requester and a responder, and no one else can listen in directly on this communication. From a developer perspective, it's well-known, trusted, secure somehow. It fits nicely into a linear programming model. You execute the request and you get the response back and continue. But it, of course, also introduces a high coupling between the requester and the responder, both in the code, but at runtime you get both a temporal and a spatial coupling. The responder has to be there and has to be reachable by the requester. For us, where we have an app and a lot is executed from the app, we have a request coming in to the backend. Synchronous request response between services on the backend fits nicely in there. It's easy. When you have a request, you have to complete. It's easy to do just another request to a service and then complete. What about the asynchronous case? Well, if you do it in the style where you're not doing events that is a command, then you get an open communication. So you can send out an event that some user did something. Just publish this event, and any other service interested in this type of event can listen in and do something about it. That is a way of communicating with a very low coupling. You only have a coupling on the level of the data you actually send. You have to agree on the contract, so you move the API down into the data. From a developer viewpoint, it's maybe a little bit insecure. It's untrusted. You send out this event, and then what happens? You have no idea if anyone is actually going to consume it. And what about if it's a part of a business process? How do you know that the consumer intended to consume this event is actually going to consume it? And maybe send out another event that you will then consume, but the code taking care of that is in a completely different place in your code base. So it's a different style of coding. And of course, it doesn't work that well if you have a request coming in from the app and you have to complete. Yes. So let's have a closer look at how this communication shapes the coupling between the services. An example, let's say that service A is a sign-up service and service B is a user service. A user applies to become a user, and sign-up service then commands the user service to create the user by calling this create user endpoint. So we have this temporal coupling and the spatial coupling, but there is also a more subtle type of coupling in the behavior here. Service A commands the other service to do something. So it's actually taking responsibility of something which should reside inside the user service. So we get this behavioral coupling between the two services, also reflected in the code. Let's look at the same example in the asynchronous case. So again, sign up here publishes an event called, let's say, user applied. And this is where, see this, it's not a command event. It's not a create user event. It's a user applied event. It says something about what happened inside the user service. The sign-up service. The user service then consumes this event, does whatever is needed when a user signs up, creates a user, and then issues an event called user created, which the sign-up service may then again consume, send a push notification to the user, hey, you're on board, welcome, and changes its state. So the behavioral coupling we had before is now gone. The sign-up service just tells everybody that, hey, someone signed up, do whatever you need. And the user service determines itself, based on consumption of an event, how to react. This idea about behavioral coupling is actually something that Ian Robinson wrote a blog post about 9 years ago. There's a link to it there. And I think it's a good way of thinking about types of coupling between services. So if you take this pattern of sending out asynchronous events across all your services, you end up with an event-driven system. A system where all changes are encoded and published as events, and the behavior of services are based on consumption of these events. In traditional system designs, the focus is on the state. So we record the state inside a service, and there might be some event causing a state change, but normally the event disappears afterwards, after we have changed the state. That's not so in the event-driven system. The focus is shifted from the state to the events, and the state is a consequence. The state change is a consequence of the events. Back in January, Randy Shoup published a blog post called Events as First-Class Citizens, where he suggests that we maybe should elevate the notion of an event to a first-class citizen in our system design handbook, at the same level as application layer and persistence layer, that we should maybe consider having an event layer and using that as a pattern in our design language. When we decided in Lunar Way to go down this road, the microservice road, we also decided that ultimately we wanted to create an event-driven system. We could see so much value in having all of these events and the loose coupling they give. However, as we would learn, there's a lot of things that can go wrong. So this brings us to, there's a link to that blog post. To our road to microservices. I'll try to present some major milestones and the learnings we had along the way. So the first microservice we did was what we call the feed service. From a business perspective, its purpose was to break away from traditional banking apps, where we have a list of transactions. We also had that to begin with, but we wanted to do something else. So we wanted to turn it into a feed where you'd have your transactions, but you could also have that mixed with messages, other stuff down the road. From a tech perspective, we wanted to start decoupling the app and the backend. So we wanted a different data model for the API towards the app. We also took a decision of not to introduce too many new technologies in one go. So we introduced Rabbit as our message broker. We shifted language to TypeScript and Node as runtime. And then, of course, the async message passing as a new architectural pattern. The choice of the language and runtime was very much based on what we did not want. We didn't want to go down the Java road due to the footprint of the JVM at runtime. And we certainly, none of us were very happy about Ruby, so Rails was not an option. Now it's getting embarrassing because we made one very big mistake. I think yesterday, at least twice, someone mentioned that one microservice should never access the data of another microservice directly. We flunked that on our first attempt. The events emitted from the Rails backend only contained the ID of the transactions. So instead of it containing the complete data that the feed service had to use, the feed service would have to go and look up the transaction in the legacy database. Don't go there. It simply creates such a big coupling, hard coupling from the feed service to the Rails legacy database. And it was bound to give us a lot of trouble down the road. And it still does. The feed service is still there, so we're still having this very hard coupling on the database level. I hope we are not the first ones to do that. Probably not. Yeah, the second learning is more obvious. It is a really good idea to reduce the number of new technologies you introduce in one go. It doesn't have anything to do with the microservices. It's just generally a good rule. If you're embarking onto new territory, don't bring in too many new technologies you have to figure out how to work with. There's a very good blog post called Choosing Boring Technology about this. And I encourage you to read that. The link is also on the slide. It's by Dan McKinley, and he suggests that over some longer period of time, you're given free tokens to bring in new technology, and you don't get a new one before the end of that time period. The rest of the technology you choose has to be boring, so well known. It relates to this hype-based architecturing. Hey, we all want to bring in this fancy new technology because it's so hyped. Think about it, because when a new technology hits production, it'll take an effort to get rid of it again. Okay, so getting the feed service into production went pretty well, and we were pleased with the result, except of the glitch about the data model. We had managed to break a tiny slice off the monolith and had success with using async message passing. So our next 3 services piggybacked on that success. We improved the tooling around our development process, and we also started to implement some small internal libs for common functionality, DB access, localization, logging, etc. This is also a tightrope walk in microservice world. Maybe you shouldn't do that when doing microservices. Again, in my opinion, it's a question of size. For a smaller team like ours, we simply cannot afford not to do it. If all services do this type of thing in its own way, it's just going to explode in too much maintenance. For a bigger team, it could be a good idea. Also, we had our first experiences with the orchestration of flows. Since we're a bank, we have to ask our users about a lot of information when they sign up. So the sign-up process is pretty complex. And it actually involves sign-up, support, feed, and the old backend. So that's an example of a saga I learned yesterday. With an emerging pattern. Events flow between these services, and eventually a user is signed up based on the different events flowing between the services. However, as you maybe remember, we did big bang deployments back then, and that had not changed. So that started to become a major pain point. Can you imagine I change something in the feed service, just a tiny little bit, and then we have to ship all of it out into production. So we started to look for dedicated DevOps resources. You don't find that kind of resource just overnight in small city like Aarhus in Denmark. So it took some time, and when we found the right team members, you also don't build a new deployment pipeline and runtime platform overnight. So it actually took, from the first of the guys started to we went live, it took actually 4 months. So this is the most important learning from that step. Prioritize your deployment pipeline and your runtime platform from the very beginning. You must be able to deploy independently. In our case, we're running Kubernetes. We went live about a year ago, and it gives us this independent deployability. Of course, also a lot more, but that's out of the scope for this talk. Okay, so around this time, about a year ago, we had Kubernetes in place. We had a handful of microservices. However, we were not completely satisfied with our choice of Node and TypeScript. TypeScript is great, but you cannot just code in TypeScript and forget that you have JavaScript sitting beneath. So in your runtime environment, it's JavaScript. So coming from a statically typed world, most of us in the tech team, we had our share of unpleasant surprises due to that fact. So we were actually looking into an alternative. We chose Go and started experimenting, got our first service into production during the summer of last year. And now all our new services are written in Go. So the learning here is choose your toolbox wisely. Again, when something hits production, it really takes an effort to get rid of it. So you have to choose the tools you're using in a well-thought manner. Right now we have, 12, 15 services written in Node. So we cannot just stop maintaining all the libs we have for Node. So right now we have to maintain the common libs or the small libs we've implemented. We have to maintain that in both languages. And again, keep your team size in mind here. If you have a big team, might not be a problem, but for our team size, we certainly don't want to bring in a third language. Secondly, you should insist on paying off technical debt. We always try to bundle a new feature we implement with some technical debt that we can sort of sneak in with that feature and pay off. All services should at all time be in a deployable state. You don't want to have a service that sort of falls behind, and then when an error hits, you first have to do a week of changes before you can actually fix it and deploy it. Okay, so we reached the summer of last year. I don't know exactly when it was, but around that time we stopped counting the services we had running. When you reach that point, having to handle certain things manually is maybe okay. Having a service that behaves a little bit different than the other services maybe also okay. But when you hit that point where you stop counting, then it's not okay anymore. So the learning here is you have to be systematic. If you're not systematic, then things will blow up in disorder and combinatorial explosion. So you have to establish some conventions and follow them for APIs, messaging, deployment pipelines, your runtime environment, naming, logging, and metrics. For example, logging. in the first incarnation of, we were using the Elk stack, and there were some differences between Rails, Go, and the Node services in how they logged. Certain fields were not present in Go, but they were in Node, and it was not completely aligned. And that's when you have to debug something, if you have to set up alerts based on your logs, it simply doesn't work. Actually, 2 days ago, or was it? No, it was yesterday when I was down here. There was a major problem back home. It wasn't due to us. It was our partner bank that had deployed something in production that broke our API. And we didn't, our alarming didn't catch it due to a field missing. Under certain circumstances, there was a field that was missing in the Rails logging. And that exactly hit that specific circumstance. So we thought we had actually gotten rid of all these misalignments, but there was still one. Secondly, so we've since last year changed to using, we replaced the Elk stack with the Humio, which is really a nice tool for doing exploration of your logs. Okay. Secondly, be dry. Dry up your services. In our experience, you should prefer small client libs backed by a service instead of a bigger lib where you have more logic. Again, due to maintenance. If you change something, you have to go around in all services and update that. So if you have the logic in a service and then just a small lib inside the other services, for example, for localization, in the first incarnation of our localization setup, each service had its own database of localization data. And a lib to access that. In our second attempt, we've moved the database of localization data into a service and then have a small library inside each service with a gRPC connection to the backend service. Likewise, the authentication middleware, we had the same learning there. To begin with, logic was inside the authentication middleware, and we moved that to the authentication service instead. So the authentication service provides the complete answer to the services calling it. So we can just skip that back to the app instead of having to do some logic and then send the result back to the app. It makes maintenance a lot easier. You can just go into the service and change what should be sent back to the app. Finally, business model changes. Consider really to encode these as events and publish it. It gives you so much freedom to design your system if you communicate in this way. And it's so easy to add in new features, making use of already existing events. Finally, if you also store these events, as we do, we store all these events in a database, it gives you an endless source of debugging and support, troubleshooting. You can see what actually did happen, the events, due to the events being stored in the database. Okay, this is a picture of what it looks like right now, last I checked. The bluish ones are Go services, the green ones are Node. All those over here are app-facing. And then we have some internal ones. The Purple one up there is in principle, just a cron job that sends out a tick every minute. Some integration components, and we still have the Rails monolith. It's still there, not completely dead yet. It's getting there, but hopefully sometime this year we'll be able to kill it completely. And then the different technologies we're using to support this. Okay. Finally, I have to speed up, I think. Some use cases of async message passing from our setup. The first use case is data enrichment. That's how we're doing that. We have one source of data, could be transactions coming from our partner bank, and we want to enrich that with, for example, geolocation information, branding of this transaction, which brand is it, other types of enrichments. That's done using events. So the source publishes an event, transaction created, and the different enrichment services consumes them, does whatever they need to do, and publishes an enrichment event containing the enrichment. And downstream aggregates can then consume both events and store that, expose it to, for example, the app. That's how we are right now presenting information in the app where we have enriched transactions with more information. Business insight. How many of you, if anyone, saw my talk, my lightning talk earlier today? That was exactly this case. How we are providing business insight across services. The same pattern. We are simply having a KPI service that subscribes on all interesting events that we want to be able to do analytics on top of. Transforms it into a traditional data warehouse, stores it in the database, and then we're using a tool on top, Periscope, to set up dashboards, etc. External APIs. Maybe you've heard of PSD2. Banks, European legislation, banks have to provide users with a means to get hold of their transaction data, and later on also to actually let third parties do transfers and payments. So we also have to do that, and we're going to implement that in completely the same way, same pattern. Have an external API service that subscribes to events, does whatever is needed to put it into the model that is suitable for this case, store it in a database, and then put an API on top. Furthermore, it's so easy to turn this into a push-based model instead. You just turn the events into webhooks and encourage your users to use the webhooks instead of polling the API. Because polling APIs are really, really bad. This is one of our major pain points. The API towards the partner bank is pull-based. So we don't know if there's new data in the partner bank. So we have to fetch it. So when a user logs in through the app, we have to do this request to the partner bank to figure out if there's no new data. If the user has used his card, then we don't know about it. It's only payments triggered from inside our app where we know that we have the data. If the card is used, we have to pull the data from the partner bank. Okay, so this happens synchronously. The user logs in. The Rails backend does the request to the partner bank, pulls down any new data, and completes the request from the app. It takes about, on average, 1.5 seconds to do this synchronous call to the partner bank. Imagine what happens if marketing accidentally pushes a message to all of our users in one go. We've seen that a few times. We call that our, not DDoS, but DSDoS, distributed self-denial of service. Because that's what happens. We exhaust, due to the long time of that request, we exhaust the Rails connection pool. And users get annoyed, they can't get into the app, so they do a pull to refresh, execute a new request, and it just piles up, and there's nothing we can do. So we have to turn that into a pseudo push-based model, and we're going to do that with the events again. So instead of the app forcing async, we'll set up a WebSocket. We actually already have this in production. It's not completely ready yet, but a WebSocket to the app, which is established when the user logs in. That triggers an event about user logged in, which will then pull data from the partner bank. That will trigger new events about whatever data, new data were fetched. And the AppSync service will subscribe to these events and push the data to the app. Yes. So wrapping up, key takeaways if entering microservice land. First, adapt to the size of your team. I think that's really important. I think you should use asynchronous communication. It has worked out really well for us. Prioritize your deployment pipeline from the start and be systematic about what you're doing. That's it.
So thanks a lot for your talk. So we have time for probably only one question. So, okay.
How did you realize the infrastructure for events? Is it a queue or topic?
It's a topic.
It's a topic?
Yeah.
And how do you handle, or you don't need to handle message duplications?
Well, on top of Rabbit, we've implemented delivery semantics very much inspired by Kafka. We're actually considering moving to Kafka instead. So we have the notion of a consumer group. So each service, if it wants to, can declare a queue using the service name as consumer group. And Rabbit then guarantees that we only get the message once to each one of the instances of the service running. However, we're also trying always to code in a style that where duplicate events is not a problem. So idempotency is really important.
So is it one event, one topic? Or one topic for all kinds of events?
We have multiple exchanges divided after the domains. So we have a transaction exchange, a user exchange. So all events having to do with the user is on the user exchange. Different consumers and producers, support service, for example, can also produce events on the user exchange, but with different routing keys. So we're using the routing key to distinguish which services should consume which events.
Okay, thank you.
Thank you. So I guess we are running out of time. So thanks a lot again, and thanks for your talk. Thank you.